Hello, welcome everybody to the fourth seminar of this year's UABB Hong Kong 2022. My name is Faye, one of the curators from this year's team. So today's seminar is about design campuses as sustainable mini cities. So now we all know that education is no longer like what we used to have decades ago. I mean, when I was a student, when I was a primary school student. Nowadays, education is more than just sitting you in a classroom, but more about crafting a living environment where kids spend time in there, learning, living, hanging out, and also experiencing a more sustainable way of living. Today, we're very happy to have three architects to join us on Zoom. And from different parts of the world to talk about and share with us what kind of campus design facilitates a more sustainable, not only imagination, but really applying the sustainable living strategies or principles into our campus design, not only in tertiary education, but also in primary and secondary. So let me introduce our first speaker, who is Mr. Li Hu. Mr. Li Hu is an award-winning architect and also the founder of Open Architecture. So one of a few of his more well-known education projects include Qingpupinghe International School and also Beijing No. 4 High School Fangshan campus. So Mr. Li Hu will talk to us about more of his projects in a little bit. So our second speaker is Mr. Zhanhe. So Mr. Zhanhe is the Director of Educational Architecture, Design and Research Center of Bay Area Planning and Design Group. His work mostly surrounds the leading of the design group in urban planning, architectural engineering, landscape engineering, and also quality inspection and project management, and all that technical services. And so Mr. Zhanhe will walk us through the latest development of China's educational architecture or campus design. Both from a policy point of view and also from a designer's point of view. And last but not least, I have my colleague, Mr. Carlos Davila, calling in from New York. It's super early. Morning, Carlos.
Morning.
Right. So Carlos specialized in building science and the environmental design. He's the leader of KPF's in-house building performance simulation team. And he worked across all the offices in KPF, handling all the sustainable features or sustainable analysis of various projects in KPF across the globe. Welcome, Carlos. Right, so we will have all our three speakers do their sharing first and then have a little Q&A session where we take in questions from the audience, not only from the live audience, but also we have Zoom audience and another, this talk is also being streamed on Facebook as well. So if you're on Facebook, don't worry, just type in your questions in the comment, and then we have our colleagues who would pass your questions to me. And if you're on Zoom, part of the presentation will be delivered in Mandarin. So you can click on the interpreter button and listen to the content in English. And if you're on Zoom, I'm sure that you're very familiar with the Q&A button function as well. Just type in your question and our guests would either answer your questions by text or in live. Before we start the Q&A session, may I invite Mr. Zhanhe to talk to us or introduce to us what is the projects that he's working on and also the current policy of educational facilities in China. So now we're going to switch to Mandarin channel. So if you need to switch to the interpreter English channel, please do so now. 好，赞先生，你现在已经准备好了吗？
好，准备好了。
好，谢谢你今天过来，然后请开始你的演讲吧，谢谢。
OK， 我们今天想聊一聊，就是关于绿色校园的这个经营设计。下一页。这个现在这个学校呢，这个建设呢，在全国的建设量已经是非常非常大的啊。这个全国到在全中国啊，全国的共有的学校就达到了53.7万所，在校的学生也有2.89亿。那么这个整个规模呢，也到了39.2亿。下一页。那么最近在深圳呢，也进行了大量的这个学校的建设，无论是中小学校还是这个大学，有的甚至都是各所大学都召开了这个国际竞赛。那么总的量是非常非常大的。那么在深圳就要建立光中小学大概要建立300多所中小学啊，在5年的时间之内建立这么大量的这个学校。那同时也有很多高校，就是像这个创意学院都是向国际招标的。下一页。那我们呢，这个在近10年之内呢，我们也都做了非常多的开始这个近100个的这个校园啊，也是这个绿色校园的一些探索。那么开始李虎先生也提到了跟我们合作的那个清华大学的海洋馆啊。在这么多学校的实践当中呢，我们也形成了我们自己绿色校园经营设计的一些特色和经验啊。我们今天主要跟大家分享一下我们在这个绿色校园设计方面的一些经验和特色。我们下一页。我们其实总结了哈，我们所有的设计都在采取这个5步法的方式啊，通过前期的对本身场地的这个条件、本身项目的这个条件进行诊断以后，再经过策划、创意设计和工程设计的方式啊，再反评估来评价这个项目，然后找到一个经营设计的一个方法。那么包含了这个预测的分析、定量的验证啊、综合的评估以及校对的调整。那么在这个5步法里面呢，实现经营呢有一个很重要的一个手段啊，我们就是通过正向的数字模拟技术啊。下一页。那么正向的数字模拟技术呢，就不同于以往啊。我们其实在学习中国的一些传统建筑的时候呢，我们也会有跟这个传统建筑的一些适应气候的一些处理手法，比如说我们南方这个传统建筑的一些冷巷骑楼的一些做法，天井的一些做法。但是呢，这个呢都是趋于经验值的，并没有做到精准的来控制这个空间的尺寸大小和定量的做分析。那么另外还有呢，就是这个数字模拟技术呢，其实也经常被用作一个事后的一个验证啊，它并没有正向的再来指导我们的设计。但是我们在做这个进行所有的绿色校园的实践中间呢，我们是把它做到一个非常重要的一个手段啊。我在这次的分享中呢，我想简单的从3个方面讲。第一个是在场地分析，第二个是在形体的生成，然后再一个就是在系统的综合运用上面，这个正向的数字模拟技术可以怎么样的帮助建筑来实现它的这个经营的技术和控制的手段。下一页，谢谢。那第一个呢是讲场地分析。下一页。这是我们在江西的一个职业教育学校啊，这个用地还是非常大，那么场地环境也比较复杂，有山有水。那么实际上在前期的过程中间呢，我们对这个地形呢进行了一些，比如说这个利用 GIS 的这个方式啊，我们进行了一些生态基底的一些分析，做了生态敏感性的分析。那么实际上这个对我们这个设计呢又起了非常非常关键的作用。那么我们有意识的要避开这些生态敏感性非常强的地方，尽量少的介入。那么同时呢，有一些这个会水的区域，会进行滴涝的区域，我们要想办法的避开，并要在实在避不开的情况下呢，我们要做适当的这个生态修复。下一页，谢谢。OK， 这个是我们也是在深圳很多年前做的一个技工学校，这个规模也比较大，这个规模大概在20多万方的样子。那么用地呢是处在一个 山地，完全的山地里面啊，只有一条小路能够通向这个校园。那么这个学校呢，这个最大的高差呢，场地内最大的高差在80米。那怎么样把这个建筑塞进这个场地，而且减少对场地的扰动，同时减少土方量，同时呢还要让这个山地的地形地貌呢不要被破坏的太厉害。所以呢，我们提出了一个叫这个公园中的学校，学校中的公园这个概念。那么通过这个数字模拟的技术呢，把这个建筑跟山地的凹口的形状能够更好的契合，尽量的减少这个对场地的干扰。那么下一页。其实呢，这个项目呢，我们还做了一些这个场地的更深层次的分析。比如说，因为山地它有可能会产生一些洪水的这个汇水面，那么我们在这个建筑布局的时候呢，也要尽量避开汇水面，把汇水面留下来。这样的话就不会造成将来对这个场地本身一些水的因素的扰动。那么这个是我们通过一些风的一些模拟情况来组织整个校园的设计。我们可以看到，在校园里面呢，我们是尽量创造一个比较舒适的风的环境啊，用风环境的这个模拟啊，包括风速的控制，我们把这个整个场地内的风速呢控制在一个人比较舒适的一个环境啊，比如说控制在3米每秒这个范畴内。那么空气灵呢，我们也是通过这个数字模拟技术呢来指导我们的优化和调整我们的建筑布局，使这个室外的空气灵呢我们控制在300秒以内啊，这个达到一个让整个室外的环境达到一个比较舒适的一个状态。下一页。这个是在我们做的南方科技大学的一个项目。那我们的整个校区呢做了一个规划的控制和布置啊。那么可以看到这个左上角的图呢，是在过程中间呢会发现啊，根据这个经验来布置的一些总图呢，又可以看到有些局部噪声会是比较影响比较大的。那么在建筑本身、建筑造型的本身和这个结合场地环境的一些手法和设计方法方面就会要有所调整。那么可能这个建筑造型就不会是完全开放的，就是特别开放的，因为受噪声的环境影响还是比较大的。所以呢，对我们的造型的影响呢，也还是要做一些消除这些声环境不利影响的一些处理的方式。包括这个建筑外立面材质的一些使用，要做到一些消声的处理。根据不同的这个面的噪声的这个影响，我们会要在建筑形体本身呢，在场地方面呢，也要做一些不同的一些区分。下一页，谢谢。这个是我们做的一些日照的一些分析。当然，这个一方面是在中国的规范中间对这个教学楼的这个日照是有一定的要求的，这是其一。其二呢，是还有一个在可再生能源的利用上面呢，我们要做一些日照的这个分析，来判断我们就是太阳能的利用要到达什么样一个程度，可以在哪个范围来使用。还有一个呢，就是在背阳面和向阳面结合热导的分析呢，我们做一些这个场地热导的一些判断和处理的手法啊。下一页，谢谢。再有一个呢，就是这个数字模拟技术在这个建筑设计中的使用，这个是我们在一个学校的一个项目中间啊，因为也是涉及到山地的建筑，所以呢，这个通风面呢还是受限的，而且场地呢，这是一个比较大的一个学校，这个空间都相对是比较大的，它是一个做一些放大型机械培训的一个学校，所以空间还是比较大的。那么单靠两侧的通风呢，是实现不了它室内的自然通风的一个效果。那么我们实际上是做了一个拔风井的一个，中间做了一个向传统建筑学习做了一个通风井的这个方式。那么通风井的位置和大小、形式它向这个各层开口的这个开口通风的这个位置和大小，都是通过这个数字模拟技术来实现的。那让它在这个最经济的条件下实现最优良的这个自然通风的效果。那么还有一部分采光的一些需求，我们也结合了一些类似于这个这个导光管这样的方式来实现。下一页，谢谢。 我们通过数字模拟技术，不但是可以说这个在我们的这个立面的窗户的这个开启方式啊，不再是仅仅是依据传统的这个我们这个从视觉的角度，或者说从美学的角度来判断，那我们也可以提高窗户的一些效率，尤其比如说通风的这个效率，保证室内通风处于一个完全比较舒适的一个方式。那么我们可以精准到每个窗户应该开在什么位置，每个开启扇应该有多大的通风的量和面积啊，这是一个完全不同于以前传统设计的一种方式。那么下一页，谢谢。甚至我们更精细的设计可以到说我们能够就每个不同位置啊、不同朝向不同高度的这个窗户做一个选择我们可以选择中悬窗平开窗和这个上悬窗。那不同的窗户的形式呢，也会造成不同的室内通风环境的一些影响下一页，谢谢。这是这个对通风窗的这个采光以及通风的不同情况的一些分析谢谢。下一页。这个同样是在室外的一些空气导流的系统在这个判断和加入以后呢，会增加有效的改善我们的这个。那么我们在做这个表皮的时候，那么表皮尤其做一些界面性的表皮，包括它的疏密的这个结构的变化，然后在不同位置哪个地方应该是要疏一点，哪个地方应该是要密一点，它会造成室内通风环境的一些变化，也是通过我们的这个数字模拟技术的正向的引导可以协助我们来做一个精准的一个设计。下一页，谢谢。包括我们这个建筑形体就是采光的这个要求，然后通风的一些要求。那么在建筑形体本身的这个形状的这个会出现一个什么样的形状？它是顺应这个气候的特点是吻合当地的这个项目所在地的这个气候环境、通风的、噪声的、日照的这个环境，它也是能够提供一个指导和帮助下一页，谢谢。另外一个呢，就是在数字模拟技术它不单是在这个建筑设计，它其实还有一些这个联动的技术，因为我们的建筑设计不只是为了能够通风好、采光好和这个噪声小，那么它其实还要兼顾到一些类似于我们的这个美的概念美学的概念，我们还兼顾到一些文脉的概念，我们还兼顾到一些城市机理的一些概念，还有一些文化记忆的概念。所以呢，并不会说在建筑设计中间，在这个数字模拟的这个结果中间，它是一个最优的解。但是呢，我们其实可以通过数字模拟技术呢，在单专业之间没办法求得最优解的时候，我们可以在多专业中间进行一些联动像这个是我们在深圳龙岗的一个学校的一个大厅的这个采光的这个关系的模拟通过不同形式，包括这个退台的高度的大小进深的大小，包括幕墙这个玻璃颜色的选择，造成室内光线的一些不一样的这个风格，包括我们这个幕墙的这个框架的这个做法，会造成室内环境的一些变化，包括室内的一些装修这个色彩的变化，会影响到这个我们室内这个采光的一些变化。这个东西都可以通过一些我们数字模拟技术来指导我们的设计，那么我们就可以在它建筑本身不是最优化的这个方案的里面，我们通过其他的一些专业的联动，像我们在建筑材质的选择，在室内装饰物的一些这个色彩材质的一些选择方面，来补充它的这个技术的这个缺陷的方面。下一页，谢谢。下一页包括还有一些 下一页。又死了吗？还有一些这个质量构建、水平质量构建的一些做法，垂直质量构建的一些做法啊，包括我们用的这个学生活动中心的一些垂直立化的一些遮阳啊等等这些方式，包括可能通过热岛的分析，可能会区域存在一些热岛反应比较热岛的这个温度提升比较高的区域，我们会加大这个绿化的面积以及地面铺装材料，比如说我们使用一些景观的一些这个透水地面的一些方式和做法，让地面的这个含水量增加，来适当改善这个热岛的效应啊。它虽然没办法通过，有的时候这个尤其像深圳，它建筑密度就是要求那么大，它的热岛是不可避免的。那我们可以通过其他专业的一些联动来改善这个热岛效应的实现啊。下一页，谢谢。另外还有一些就是开始讲到的一些景观元素的一些利用，比如说这个因为热岛的因为噪声的因为一些水处理的一些方面的一些因素，我们都可以通过这个数字模拟的技术来有针对性的来不同的点来解决一些可能存在的一些不利的点。谢谢，下一页。下一页，谢谢。这个是一些在这个南方科大的一些项目中间针对不同的这个区域的采光特点，使用的色彩不同的室内的装饰的环境。那么这个也是在南湾区域更大的层面在整个校园层面，在热岛效应比较开始我讲到的热岛效应比较强的，就是一些组团中间像这个实验组团我们的教师公寓的组团以及学生书院的一些组团，因为建筑密度相对而言比较高所以呢它这个通过日照的分析呢，它有可能这个地方首先它是长期处于这个阴影范围线以内的，那么它可能在我们景观的设计上绿化植物的选择上，就应该选择一些喜阴的植物。那么在长期处于向阳的区域的时候，我们可能要选择一些喜阳的一些植物来配置，这样的话就会各个专业就能够联动起来综合达到最高的一个高效的一个利用。下一页，谢谢。包括通过一些我开始也讲到，就是建筑它不可能说它的建筑这个本身的创作和设计完全是这个物理环境的最优，那么它可能也要考虑到其他的因素，那么必然会造成一些物理环境出现的一些问题，比如说热岛的效应当然还有一些像这个通风环境，我们希望控制的这个目标，实际上在某些局部的区域很难达到的时候，我们实际上也可以联动这个景观的设计比如说我们有一些高大乔木或者有比较密集的这个树林来降低这些风速，或者甚至我们有一些通风廊道来提高风速，那让这个风道周边的这个建筑物的这个表面相对比较光滑，相对而言比较光滑一点，这样呢提高它的风速，来解决整个校园的一些问题。那么实际上，所以说数字模拟技术呢，在这个在正向的指导的时候呢，它会给建筑带来一个不同的一个感受除了是这个物理环境的感受以外，它也会让你的建筑的这个不管是在形体还是在总平面总图的布置以及材质的选择立面形象的展示，都会出现一个不一样的结果，而且它会更加的精准更加的符合它实际本身的内在的逻辑。下一页这就是我今天想，因为时间有限，我也只是分享我们在这个绿色校园设计的创作的过程中所积累的一些经验，当然还有很多一些方法和手法希望大家相互交流谢谢。OK。
好，谢谢段总。So our next speaker is Mr. Carlos Davila. So Carlos, are you ready?
I am. Can you hear me?
Yes, perfectly. So please start your presentation.
All right. Thank you. Thank you so much for having me. I'm very happy to be here and very excited and curious about the other two presentations. I'll talk in my case, focusing mainly on one project, which has been a very important project for our office and very transformational project for our office. Is the design of the Hong Kong University of Science and Technology campus in Guangzhou, which has been very important for us because it has allowed us to address and consider issues of sustainability and in particular of climate action at the speed that most of our other projects don't allow us. I wanted to start by putting it in context of sort of like recent events, right? So we are coming out of a year where we've had both some of the highest or the most important floods in southern China related by climate change. And we're also coming out of COP27 in Egypt, where there has been this focus on adaptation as such an important topic equivalent to mitigation and reduction of carbon emissions. And this is a very interesting moment to think about this project, which we are finishing now, and to think about climate action in general. If you go to the next slide. Because some of the questions that we had to face in this project now completed are the same questions that a lot of our work is posing around the world, right? KPF, you see here our work, our active projects distributed globally. And we know that many of them, especially those in Southeast Asia, are areas that are going to see some of the most dramatic changes in temperature, in frequency of storms, in flooding, and so on. So that forces us, if you go to the next slide, think carefully about how do we design our projects, not only, as I was saying earlier, from a perspective of reducing carbon emissions. We are, as a company, committed to the AIA 2030 target and to find ways to design carbon neutral buildings by the end of these decades. But also, if you go to the next one, to really look at projects through a lens that not only considers how do we reduce emissions in materials and in buildings and in transportation, how do we design for a decarbonized world, but very much how do we design for this uncertain climate and for places like the site that I am going to be talking about, where this was a priority since the beginning. So if you go one more slide and moving actually into the project. So what did this mean for HKUST? Well, when we were approached to design the campus, to plan and design the campus in 2019, it was a very interesting project from the beginning, given where it is and its relationship with the main HKUST campus in Hong Kong in Clearwater Bay. We were tasked to design this sister school. Go to the next slide. And what from an academic perspective seems like a relatively simple proposition, right? We're just an program expansion of types of research and so on. When you come to the site, you realize it's a much, much larger challenge. Because the site of the new project, which you can see in pink there to the upper left, is by the river in the Nansha area, and a site that is already effectively flooding every year with certain regularity, that is only going to get worse in an area which is very hot, very humid, not necessarily with a lot of winds for most of the time, and where HKUST tasked us to design effectively a carbon neutral or a carbon neutral ready campus. So with that mandate, we started the project. Go to the next slide, please. And we work very closely with the university, trying to identify which would be the principles and the main ideas that are going to drive the design and that we needed to achieve here. And it's very interesting. Some of these ideas have already come up in the previous presentations, but in addition to the carbon neutrality goal, which we're supposed to design a campus that could be carbon neutral before 2060, which is the national China goal as a country, there are two other big ideas that came out. One, it had to be a campus that can really adapt and become as future-proof as possible. And that drove a lot of the decision-making in terms of design, because what the university asked us to do was to, rather than put the newest technology in every building or in every mechanical system, rather to put the necessary infrastructure so that the campus was never limited in its capacity to become better and to improve. So that's one big idea, sort of like long-term thinking. The other big idea is this idea of a living lab campus. And this came up at the beginning, and Faye brought it up, Mr. Lee brought it up as well, right? How the architecture and the systems can support the education and the enrichment of those that are using and learning in the campus. So if you go to the next slide, just to give you an overview of the project itself, this is phase one of the campus. This is what we just completed. It's a very, very large site, which we've so far occupied about even maybe less than half of it, surrounded by canals that includes a mix of very intense graduate research for both engineering and sciences, and then a huge mix of users. This is truly a small city. We were talking about 40 buildings, 10,000 students. So really a very significant urban community. The next slide. So as we approach the site and we try to marry this very complex natural environment with the purpose of the university, the master plan is largely driven by this idea of a central hub, which is where most of the research and educational activities are concentrated. And then the rest of the campus is planned radially to some degree around it, because one of the main, as I mentioned earlier, one of the main objectives is to allow the campus to grow and to change and to improve. So that way it was possible to grow both to the east and to the west without necessarily having to do a new center. Other uses are structured around it with this idea of embracing the local nature and leaving as much of the campus empty, right? So since the beginning, we decided not to build the whole thing, but rather to give as much as possible to the local wetlands and local natural systems to some degree mitigate the flooding and the in terms of program, and this is to give you a very general idea of the project, I'm not going to get into a lot of detail of the architecture itself, but the central hub includes this large number of orange lab buildings. These are relatively large research buildings, which are meant to be very flexible because there's a number of potential research that could happen in them. Those surround the central courtyard that includes a library, student facilities, administration, and so on. And then to the north, you have faculty housing, those purple buildings. And to the southeast, you have student and faculty housing in an area that we call the High Street, and to be an interaction point between the campus and the new developments that are happening around. Next. Focusing a little bit more into that central hub, which I think is probably the most unique and the most critical space of the project. This whole cluster of buildings is really designed as a very large mega structure that overlaps architecture and nature, that is really thought through to encourage collaboration. So you have these long corridors to the sides, which we call the concourses, that includes collaboration spaces, faculty offices, maker spaces, with a lot of opportunities to go outside, to be naturally ventilated spaces. And then there's a continuous loop that runs throughout the courtyard that allows students and visitors to really walk comfortably from any research lab to any other research lab in less than 5 minutes. And this is that space today. These pictures are actually from last week, so it's been really, really exciting to see the project finished. You will see it soon with the vegetation a little bit more grown and with more people walking around. But the space is a very, very exciting space. Really looking forward to get there and visit. Next. Now, probably one of the most interesting aspects of the project, and something that drove a lot what was possible to do in terms of sustainability and planning, is the speed, at least from our perspective as a US, or from my perspective in the US, is that it's an incredibly fast project, right? From the beginning, the first workshops working with FKUST very closely to define the goals of the project, to the moment that we finish construction, the documentation for all of those buildings, we're talking about 18 months only. And then that kick-started a process of construction that went also very, very fast. And the result of this is that in order to achieve all of the goals of the project, we had to work incredibly closely with the university, with our partners and consultants, to a degree that I personally haven't really had in any other project, of like almost daily meetings at night from the US, and with our Hong Kong office, in which meetings in which Faye has been involved more than once, that resulted into a project that captured most that we wanted of it. If you go to the next slide. looked like this in May of 2021. So this is about a year and a half ago. Go to the next slide. About a year ago now, so last December. Next. And then you've seen it in the previous image, or in this image finished as of last week, right? So we are talking about 3 years from the first idea came to the paper to the campus being open and in operation. So it's been an incredible journey. And what I want to do now is to take those 3 big ideas that I mentioned at the beginning that drove the sustainability story, and then talk a little bit about how those were integrated in the design and how we made it work, right? So the first point is this idea of carbon neutrality. There's this goal for the campus of not being carbon neutral day one, but being ready for 2060. And this is a kind of multi-step process that starts by designing the buildings very carefully, focusing on passive design, then capturing energy where possible between buildings, within buildings, introducing renewables. The whole campus is designed so that it could accommodate a utility scale, very large solar PV canopy that covers about 10% of the campus energy, and then providing a lot of opportunities for metering and improvement. All of those things together with the improvement in the grid in the region predicted or planned for the future should be able to bring the campus to being fully carbon neutral without having to resort to offsets if the university doesn't want to. Next. So for example, some aspects of the design that are supporting these ideas, if you look at the layout of the campus, is all very carefully laid out so that the main buildings are always facing south, west orientations, which are the most problematic, or southwest orientations, which are the most problematic, are for the most part avoided. And then the main public spaces are all open and analyzed through wind simulation to make sure that we get breezes through and we can keep them comfortable. Then this idea translates into the buildings. I think that there's a huge diversity of textures and facade finish approaches, but the idea in all of them was to bring the amount of glass down, to introduce shading in different forms, and to make sure that we could keep very transparent buildings to bring a lot of daylight inside, and at the same time to make sure that the peak cooling loads were manageable and that the buildings could achieve the energy efficiency that we were looking for. Next. In some of them, and I think this has been mentioned before in some of the other presentations, it's really interesting to see how far you can take naturally ventilated spaces in even these very hot and humid climates. So we very carefully analyzed the program of the campus and identified a number of spaces that could, at lower internal loads, be naturally ventilated and engage directly with the outside. An example is this. This is the library central atrium that is at the top and provides cooling for about half of the year, not to the main book stacks, but to all of the student study spaces and collaboration spaces in the bottom of the building. We're designing the buildings and thinking about their specific systems and requirements and the architecture itself. I think one of the most interesting aspects of this project is because we're designing a small city, we have an incredible diversity of use of resources conditions, right? So some buildings need a lot of hot water, other buildings need a lot of cold water. Some buildings produce a lot of organic wastes, others produce a lot of dirty water. So since the beginning, there was this circular idea of let's find any possible waste source in the campus, then make sure that it's reused somewhere. We ended up building this very complex system that you see here in the diagram, where there are a lot of these closed loops, right? So wastewater is used for irrigation, something relatively typical in these campuses, but then some of it is also used for biomass fuel production. The data center is connected to the larger energy system. So the result of all of that is that there's a very significant reduction of resources across the board. If you go to the next slide. So when you look at the systems in campus, I think probably the most interesting and the most unique of those solutions is our district cooling system, which is not only fully electric and already increases the efficiency across the campus, but it has two special characteristics, let's say. One is that we don't have one energy center only. We have one big energy center, which is that blue building that you see in the top, and then individual chiller plants only in the lab buildings, so that when the temperatures are really nice and you don't really need cooling anywhere except the labs, you can turn off everything else. And then the second big idea is that there's a big data center that is designed to work with the energy centers right next to it in red, and is designed to work with it because all of the heat exhausted or required to eliminate from the data center cooling and the district center cooling is used to be captured and then reused for hot water production in campus. So effectively, over 95% of all of the hot water consumed in campus comes for free and is produced in that data center, also saving water that we don't need to use for evaporative cooling. Next. As a result of all of these and working with ROPE and doing calculations, we designed the campus so that when it opens and is fully operational, it should be using about 40% less carbon emissions than what Kohn campus would do. And then as it moves in the future, if you go to the next slide, we've done some projections working with the university of what the grid might do, how would the solar generation improve, how would the university improve its own operations and policies to make sure that it can get to zero by the target date. The second big topic that I mentioned at the beginning, right? It's not only about this long-term approach to carbon reduction, but a long-term approach to keeping the campus safe and to making sure that it's able to endure all of the changes and all of the uncertainties that might come with its site and with its climate. Said water critical in these sites, right? So we knew that there were going to be flooding issues. In fact, we had to develop a hydrology model for the site that went further than what Nansha had available. Nansha had only planning of what would happen to these canals in a 100-year storm. We needed to look at a 200-year storm in a climate change condition. And after all of these analyses, we realized that there were really two options. One was to accept the flooding, and the other one was to raise the whole site 3, 4, 5 meters of soil, which would be an incredibly unsustainable way of addressing a site like this. So we took the first path, and a big part of the project was, as you see in the diagrams to the right, identifying which areas of the campus we needed to protect even in the worst conditions. So, for example, all of the critical research labs are elevated enough, and all the mechanical equipment is elevated enough that even if the whole site floods and the river pumps fail, they would stay safe and dry. And the rest of the spaces in the campus are designed in a gradient, right? So some of them will flood sometimes, and it's okay. Never have any water. That influenced the larger resilience strategy that starts with that kind of overall planning condition of the terrain, but also goes to smaller questions. We have this whole network of biosoils and rain gardens that you see there in green that retain the majority of rainwater. Emergency power is very carefully studied in different areas so that if something happens, different parts of the campus can operate independently. Next. Just to give you a sense of how these biosoils and rain gardens work and look, you can see there in the picture, this is an aerial of the entry area of the campus where all of these gardens are already in place, right? And it's comes into the campus. So if there's an excess of water, it can be managed. The second of resilience and adaptation has to do with climate. And we did a lot of studies of effective temperatures, and it became critical or clear very quickly that it's not only shading and ventilation, but we needed to really understand microclimates and how things like ceiling fans, things like outdoor cooling might help to keep critical parts of the campus always comfortable, because we want people to go outside, we want people to collaborate, to bike around, even in the summer. So if you go to the next slide, throughout the design process, there was a lot of studies like these of very carefully understanding what are going to be temperatures in different spaces, and then how do we make sure that the network of key pedestrian connections, which you see highlighted there, are going to stay comfortable and shaded whatever happens. And that drove the planting, that drove the selection of tree species, and that drove the architecture. So we can confidently say that somebody can walk from one corner to the campus to the other, always shaded, and stay relatively comfortable, even in a very, very bad heat wave. Next. And this is, the central courtyard, probably one of the most interesting aspects of these. You can walk below those ovals and around the canal and be always protected and always covered and always with breeze. Next. And just to finish, because I'm at the end of my time, going back to this idea of the living lab, right? How the university, HKUST, really wanted data and research to not only be available for the researchers, but really allow the campus to be an ongoing experiment, a campus that is always improving. So if you go to the next slide, one big idea was everything needs to be measured, right? We worked with Arup on a concept for the campus where temperature, electricity consumption, water consumption is measured almost at the scale of every room across the board. It's centralized, it's made available to students and facilities, and can be visualized in this very large double-height campus brain. Next. That infrastructure supports a number of spaces in the campus design, specifically of research facilities. So we have residential buildings that have a water lab in the basement available for researchers. Our energy center has research areas as well, so people can understand what's happening with the energy systems on campus. There's an AV and electric vehicle lab that is connected to the loop across the campus. There are water quality sensors in the canals. So there is a lot of infrastructure from day one there, so that the university can use it to make sure that the campus is better every year. And that when we visited, if you go to the next slide, in 5 and 20 years, that the campus is only getting better and closer to its goals. And next, I'm going to finish. And I hope that you have a chance to visit it. You're closer to it than I am, and that you enjoy it. Thank you.
Thank you, Carlos. Oh my God, I almost get emotional just looking at these slides. So now we're on to the Q&A time. So audience who are on Zoom or Facebook, please feel free to type in your questions at the Q&A button or at the Facebook comments. And audience here with me, feel free to raise your hand if you have a question. 可以用廣東話問又得，用國語問也可以，in English of course, that would be great. So just raise your hand if you have a question, and then our colleague will pass you the microphone. But let me start off with the first question. So we all know that doing a sustainable campus usually, or anything that has the name of sustainable something something, usually means either it's slightly more expensive now and it will pay off later, or it's more tricky to do the operation, or it just takes more time and effort for both the designer and the end users to do the design or to do the front face of the work. So obviously, to pull off this kind of campus design requires close collaboration with not only the end users, but also whoever that is supplying the funding, be it the government, be it the international school body, be it the patron. So from a designer's perspective, from an architect's perspective, could you share with us what are some of the key elements in terms of this kind of collaboration and challenges that you would face? So let me repeat in Mandarin. 我们都知道做这种比较环保的校园设计，或者是说比较在设计上非常注重可持续性的校园设计，通常会牵涉到，比如说比较贵，它的设计时间可能比较长，或者是它的经营这校园的成本会比较高。甚至乎就是你在建造这个校园的时候，今天你的花费可能比较高，然后在未来的10年、20年、30年，它慢慢的那个营运成本它就会降低。那所以做这种校园设计的时候，通常跟我们的客户或者是跟当地的政府是一个共同的协作关系啦。那所以可以分享一下您在做这种校园设计的时候的经历，怎么样去把这个跟学校或者是跟政府的关系，或者怎么样去让他们也明白这种可持续校园设计的重要性。So may I invite Li Hu to share with us in this regard first?
Okay. Well, this is a rather large topic, and I think we can spend an hour to debate, because I may bring in some kind of unconventional opinions. I'm a huge doubt of technical sustainability. Although myself has been involved in the very first LEED Platinum building in China, the very first LEED sustainable community in China, the largest LEED Gold building in China, and the first project I showed, the garden school, is the very first, the Chinese standard 3-star high school. The reason I have a doubt is that, you know, if you do some research, some investigation discovered that some of the so-called sustainable building ends up using more energy. It's actually very simple, because if you seek comfort, that you will very likely consume more energy, although how much you try to minimize the energy use, you are using more. Then what if you try to propose a notion that let's just use less energy? Let's try to change our concept of comfort. For instance, in the climate of Suzhou, where we have planned the gym to have the entire building floating, so the ground floor sliding glass can open. So it's for more than half the months of the usage, you don't need air conditioning. You know, sometimes maybe a little bit humid, sometimes maybe a little bit cold, but our body should be able to adapt to that. So to put a more blunt way, the most sustainable building is to minimize the energy use. Minimize it. Let's say you don't use AC. So that's even more progressive than passive, just trying to minimize the usage. I think we need to educate the people to try to adapt to a wider, you know, comfort zone. Okay, so this is my ideal. I'm trying to push that idea. But of course, in the buildings we still have to provide AC. But let's hopefully, by making more natural light, by making more ventilation, you know, we can just let people slowly turn less, you know, turn on less of the air conditioning, turn less of the you know, the light. I think that's possible. That so much of the notion of sustainability and the whole design of perfectly sealed package of the buildings come from building from cold climate. And I think if we consider Asia, much of the population live in the more kind of mild climate, everything to be rethought of. You know, not many decades ago, people lived with no air conditioning. Now we survived thousands of years of, you know, humanity with a record. So this is what I want to use every opportunity to try to challenge the whole notion. But if you do need to put in the air conditioning, of course, there's a whole kind of list of things that you can do, but it's known by everyone. There's no trick. More importantly is through your planning and your design, how you can let people use less and be open to less, you know, to make yourself more adaptable. I think that's the ultimate goal. And also to repeat what I brought in, the idea at the very beginning is that there's not just the energy, the materials in terms of sustainability. There's kind of spiritual sustainability, which is to keep the well-being of us psychologically, you know, being a good social animal, being a good person with interesting personality can develop from the whole environment. And that to me is probably far more important than, you know, what we normally do, all this kind of practice by the engineers. Okay, that's my opinion to your answer, to your questions.
Right. So your way of pulling it off is to educate the end user or the school body to accept a different notion or a different level of comfort, or redefine their level of comfort and get used to things like naturally ventilated space.
That could be misleading. That could be misleading. I am using this opportunity to put in a bigger agenda. Of course, I said we do need to provide air conditioning. Like we put in more efficient systems. But you know, the things I showed today, there are maybe more than others. You know, building with poorly designed systems, but they are not expensive. They're not that expensive, and these are the buildings being owned either by the government or by a private entity who own the schools or universities. It's not entirely difficult to convince them if you tell them the theory of the life cycle expenses. But again, that is indifferent from any buildings you do. Right? You do a housing, you do an office, but I think school provide a different opportunity that you can use the school as a kind of a opportunity for education. And the other thing I think besides the energy use is how to make the building last longer. I think that is often an ignored topic. You know, for instance, you can make a building with a plaster, stucco, which often save the money up front. But if you make the building that maintenance free, for instance, I will give you an example. The two buildings I showed today may be controversial, even though if I put this building in Europe, people can tell, why do you use concrete? Why concrete, right? I don't know if you have the similar idea in Hong Kong, but people immediately get the question, why concrete? So here's the debate. Now, when you have a solid wall, you have a different options of materials. In the case of our building in Tsinghua, the Ocean Research Building, that's one of the tallest concrete walls, 60 meters tall. Why I did the concrete instead of doing stucco neighbor buildings? The neighbor buildings, when I was starting the project, they were redoing all stucco, entire campus, costing millions of money, doing the facade again. That is only 7 or 6 years after those buildings were finished. So likewise in Suzhou as well. So I think we, as architects, we need to consider the materials in the long lifespan, which requires as little maintenance as possible, especially for school where they have no capacity to maintain the building. Okay.
Thank you. So looking at this end user participation or collaborative design process, and bringing the end user on board and doing this kind of sustainable features. Carlos, what's your take on that? Because you are usually the one who's pushing forward these sustainable features in all our projects. Are there any tricks that you do?
Had a lot of tricks to solve the issue, but I mean, I think it's really difficult. However you approach sustainability, and I very much agree with Mr. Lee that sustainability as it through systems of certification being 3-star or something like that is a really flawed process. It's neither looking at the user nor looking at the tricks, right? At the things that we care about, which in the end is a measured energy or measured water or whatever it is that we're talking about, right? I think that they're useful to some extent because they help, and it goes to your question, Faye. I think systems like that are a tool to keep some types of clients honest, right? And this is what is so different between a school. I agree, a school is a very different animal, and one that allows for a type of change that we don't have in other types of buildings, right? So I work in a lot of different buildings. I work a lot in core and shell offices. And when you're dealing with a commercial developer, you don't really have a space or a leverage to work with them and convince them of how certain things might be a better solution, or to accept a different comfort standard or a different way of understanding a building. And you don't even have access to the tenant, right? So you don't have access to the end user. In that instance, something like LEED is useful because there's a contract that we can share with a client and say, okay, we commit and you commit to do at least this little bit, right? But I think that the opportunity or the trick, if you will, that you have when you're working in a project like the one that I showed, or any other university projects, we have a number of other university projects across the world, is that you suddenly have access to both the client, university, the person that is going to operate the technical side of the building, and the community that is going to use it. So not only you can educate them, which in some cases we can, right? And often they educate us more than we educate them, I feel. But you have the chance to agree on a way of defining what the success of the building is and what their environmental goals are, right? So to come and tell them, and this was incredibly true in HKUST, you don't have to come and tell them this is what a sustainable building is, because they know what they're looking for, right? They know that they want to spend the money that they have wisely. They know that complicated technologies or things that require a lot of maintenance are bad because they have to deal with them for the next 50, 100 years. So you have an opportunity there to have a conversation where I think the only thing that I learned in that process, or the only trick, is that you're not going to tell the school community what it is. You're going to have to come up with an agreement of how we're going to make decisions together. And that worked really well in HKUST. And it was all, as I mentioned in the presentation, all focused on this long-term way of thinking, right? So we would propose very advanced things, like, what about this very fancy system? And it was like, no. We want you to put in the campus only things that we could not put in the future. So we prefer to spend the money on better glass and insulation and more long-lasting materials, and to build less. And that's, I think, the critical idea, right? Like, the most sustainable building is the one you don't build, right? So let's not build the whole campus at once. Let's build less and well, so that in the future, if we want to put a fancy technology, in 20 years we can. But don't put in the building this very, very technical, complex thing that is very new today, but that in 20 years is going to be obsolete. Let's make decisions through that lens. And this came from them. So I think the trick, or the first thing I would suggest anybody working in a project like this, is to sit down with all of the communities that you're going to be working with, the people that need to leave the building and accept it, and then agree on how do you want to decide what is a successful or a non-successful part of the project.
Thank you, Carlos. 战总，你觉得在这个怎么样跟学校校方，或者是我们现在如果做校园的话，我们的客户群去沟通，怎么样去把他们也理解这个可持续校园的设计的重要？您有什么见解吗？
实际上是这样，就是我们做校园呢，也做了，就是我们最早的校园的这个案例呢，可以追溯到大概20多年前。那个时候我们开始提这个可持续发展的理念以及绿色的理念的时候呢，确确实实是不被大多数人来理解的啊。这个跟这个民众普遍的意识，这个环保的意识，以及当时的经济水平也是有相关的啊。但是近几年的这个沟通呢，会显得更加容易啊，不管是政府也好，还是因为中国的学校呢，还是大部分都是由这个政府来投资的。那么目前呢，实际上是在政府在牵引着这个可持续发展的这个路径啊，在倡导这个可持续发展的这个方向。因此呢，现在跟校方的沟通也好呢，还是跟这个政府的沟通呢，我们觉得还是比较顺畅的。但是确实也存在一个问题，就是我们可能追求的就是在政府而言，在 政府而言，它追求的是一个结果啊，就是比如说实际的这个能源的节约碳排放的节约，但是就学校而言呢，他可能在乎的是他眼睛所看到的结果，不只是说能源的节约，他会觉得说你的学校会更加的贴近自然，有更舒适的这个环境啊，所以总的来讲，我们其实觉得这几年的沟通会顺畅很多。其实有的时候还不一定是我们来提这个可持续发展的这个想法或者理念，其实校方和投资方他也会有这个需求而且这个越来越多的人在关注这个，这是其一。其二呢，其实我们一直在可持续发展这个校园的这个方向和理念呢，也不是说一定要用高技的东西，像我们现在在哪怕是在深圳，就是相对投资额，这个学校的投资额要高很多的，在跟全国比起来要高很多的。我所知道的，深圳的这个中小学校的这个投资，单方的投资大概在8000人民币，也就是大概在1200到1500美元1平方米的这个投资额的情况下，所以呢，这个完全去用高技的方式和方法来做这个绿色校园，其实还是存在很多的困难，也不可实现的。那我们的路线和理念呢，其实也一直是希望，第一个是向我们传统建筑的学习，另外一个是我们通过建筑设计本身的这种方式和方法，比如说我在我的分享里面谈到的，我们高效的利用这个本身自然的一些资源和环境，比如说利用它的自然通风，利用自然采光，然后隔绝一些不利的因素的影响我们其实没有谈到一些高效的高技的，我觉得那个可能还是一个锦上添花的事情。我们本身还是要从建筑设计本身的出发，让建筑适合这个环境，适合这个气候条件，让它更好的体现它本身建筑设计本身的高效所以在这个方面呢，就关于这个费用高或者费用低的问题呢，其实不会有太大的变化。我们在中国内地实践的大陆实践的这个经验呢，它不会有太大的变化。我们预估的像中国现在有绿色建筑跟LEED的跟 BREEAM 也一样的，它也有个星级的这个等级。那么最高级的呢是3星级，我们曾经做到的3星级的这个增量成本大概在增加的这个成本大概在50到60美金每平方米这样的一个水准，就是几乎可以，就是完全是可以承受得了的。所以呢，这个更多的呢，我们是希望通过建筑设计本身的一些方式和方法改进我们的这个设计的方法，然后来提升这个对自然资源的一个利用的效率减少这个碳的排放就是也跟李虎先生讲的是一样，就是要降低这个，想办法降低人的这个需求，而不是说无限制的去索取所以我觉得这个目前在中国大陆来实现这种可持续发展的校园建设和设计的时候呢，其实在沟通上面和这个造价上面不会存在很大的问题。
哇，能做到绿建3星，而且成本的增加只是60美金1平米这个在这个讲座后面之后我得要请教你怎么样能达到这个。
不是现在一个数据，就像我们自己的这个大楼，大概我们的增量成本大概在300多到400块钱人民币这个样子。我们总的这个投资成本大概在4500，所有的这个费用加起来，
对，4500，然后里面已经包含了所增加的4500是人民币。
对。
OK， 所以4500里面就包含了刚才所说的增加的60块美金，也就是大概450块人民币左右。理解，这也是一个。
而且我们这个图呢，是因为它有带一些示范的作用，它不是说满足需求来设计的，它可能是超过需求来设计。
就是
当然这个楼是在09年啊，在10来年前来做的这个项目啊，可能这个本身这个物价的增长也会有这个因素在里头。
理解，反正就是它是一个超前的项目啦，所以有一个刚才 Carlos 有提到一个词叫 future proof，这也是带到我在 Zoom 上面收到的一个观众的问题了，就是我们的学生的需求是每天都在变化的，然后我们的气候也是每天在变化。我希望我们的翻译员有能翻译到。那所以现在的校园要做到可持续发展，其实它更重要的是一个flexibility, adaptability， 就是它的运作起来的弹性和怎么样能去适应我们不同的每天都在改变的需求，还有我们的气候的变化。那可能这个先请 Carlos 来讲一下吧。So Carlos, I hope the translator did translate the question. It's pretty simple. It's about how do we do future-proof design in, especially for campus design, because not only for the climate change, but also for flexibility and adaptability to suit the ever-changing needs of a school campus, be it the student body, the makeup of the student body changes, or the need changes. So how do we do this kind of future-proof design?
So, I mean, I think from a sustainability and the sustainability side of things, I talked about it in the presentation. I'm not gonna talk maybe about the project much more. I mentioned maybe that it's a really interesting question as it relates to how you invest in projects. And to give a different example of a different project, we're working now in a laboratory building in New York, where the priorities are a little bit different, of course. And one of the biggest questions that all universities are making is, do I need to make fully electric buildings that don't use non-electric heating or not today, or do I have to wait? So the question of future proofing and how do you invest money in academic buildings from this kind of carbon energy perspective becomes a lot about analyzing multiple scenarios and really trying to understand when do they want to take a risk, right? So you can take the risk of investing now in a system, or you can take a risk of waiting. And if you wait, then our role as designers is to make sure that the building can adapt to live in the appropriate spaces, sizing electrical infrastructure to accommodate whatever needs to come and so on, right? So it's an exercise on scenario planning, which is really interesting because as a type of analysis, like infrastructure planners do a lot and transportation planners do a lot, but architects don't do as much, right? It's designing one thing multiple times and sort of trying to project in each one of those cases, and then letting a client decide which one is more likely to give them less risk in the future, right? But when we talk about more, I think, program, HKUST was a very interesting project because it's a research campus, but nobody knew what the research was going to be, right? So we had to design it's like 8, 6, 7-story lab buildings where HKUST knows they're going to do research on, I think it's 8 different core areas, but there is no list of researchers. There's no list of equipment. So you almost have to design every building to become a computer lab or the most sophisticated biomedical lab at the same time. And those have very, very different requirements. So I think what a lot of the work and what becomes key, make sure that the permanent elements in the building, and Mr. Lee alluded to these earlier as well, right, are there to stay for the long term, and you're not going to have to replace them. So in our case, it became a question of structural grids and distances from the facade and sizes of cores. So that is almost like a number of core and shell spec labs, right? That years they could completely change the research, and the floor-to-floor height would still work, the structure would still work, the vibration would still work. And this means over-investing at the beginning, right? If you want a lab to work for 10 different things, you need to make the structure a little bit bigger, the floors a little bit more rigid. So question about robust design, right? And you don't put your money in finishes, you don't put your money in lighting systems, you put it in those oversized elements, oversized electrical support, oversized structure, so that whatever happens, the building can take it. But it's really interesting because you design differently. You have less control, right? You cannot leave things as finished. You need to leave things somewhat open so that in the future it's possible to adapt them. I don't know if that answers the question, Faye, or not.
Yes, you did. In a way that I did not imagine you would. Thank you, Carlos. Do we have any more questions from the audience? Because we have a few minutes left, and if we don't have any questions from the live audience, I'll just keep going with the online questions. The next online questions that I got is about, let me see, funding. So I think this question is would be more for our counterparts in the mainland. So 战总，刚才你有提过说，国家的政策是往绿色建筑方向发展，可是有extra funding， 就是有特别的增加的款项去做这种可持续建筑吗？还是其实没有，只是大家的要求比较高而已，就是要求变高，可是资金并没有增多。这个做校园是不是这种情况啊？
这个国内的这个体系呢，有点跟尤其在政府，尤其由政府来投资的项目呢，跟境外的这个体系的有一些不一样的地方。比方说，我们有一个叫国际发展改革委员会，那么由这个呢来审批这个资金。我们曾经跟深圳市的发改委呢有一个合作，就是可以在这个投资中间来单列这个绿色建筑发展的这个相关的增加的投资的这个额度。那么所以说呢，在这个投资的额度中间呢，现在是已经有单列这个项了，包括不单是绿色建筑，那包括还有一些我们现在在倡导的做这个海绵的这个技术啊。所以呢，这个一方面是有很多城市都有会把这个目标来单列的。那同时呢，即使不再单列这个增加的费用的时候呢，它也会定出这个学校的目标。那如果说这个针对国家的绿色建筑星级标准，那么是1星、2星或者3星不同的这个目标，它会投资额度会有变化，会有不一样的。那同时呢，实际上我们我开始也说到，就是实际上我们增加的额度并不大。所以呢，即使没有单独列这个额度呢，我们也是可以在这个原有的投资范畴里面来实现这个绿色建筑的目标或者绿色校园的这个目标。关键的核心呢是说你愿意把这个钱花在哪儿啊？是像这个李虎先生开始说的，我们实在去往墙上贴这个石材，还是说怎么样来把这个钱花在这个刀刃上？我们可以在比如说使用进行一些结构的优化，进行一些空间的优化减少一些不必要的投资的情况下来把这部分钱放在这个绿色这个目标的这个实现上面来。所以综合以上因素呢，其实在国内的这些一些项目就是其实在正常情况下都是还是可以实现它本身的这个投资的目标的。
好，谢谢湛先生的回复。Today I learned a lot about not only on the architecture side, but also on how to realize sustainable campus design and the importance of it. Thank you, Mr. Lee. 谢謝湛總. Thank you, Carlos, for staying with us this early in the morning. And thank you for the live audience. I know it's after work time, and also our audience online. This is our final seminar with UABB 2022 Hong Kong side, but our UABB Shenzhen side is going to start very soon, next week, I think, right? Early December. on the 9th of December, I think. So before you leave, please scan our QR code, and if not, or if you're online or in person, you can do this questionnaire for us as well. Thank you very much to our speakers and to our audience, and hope to see you all in our UABB Shenzhen events very soon. Thank you.